Welcome to part 2 of Notes 9.08, Special Right Triangle. There's a little pattern that forms with our 45, 45, 90 right triangle, which is an isosceles right triangle. And on the next page, we're going to look at what's called the 30, 60, 90 triangle. But just to kind of explain the process here, if we had a right triangle that was isosceles, meaning two equal sides, there's a pattern that forms. When we know each of the sides, let's say are 5 and 5, because it's isosceles, in order to find the hypotenuse, we take 5 squared plus 5 squared equals c squared. Combining 25 and 25, we get 50 equals c squared. And since we're adding perfect squares together, when we go to simplify, it becomes 5 radical 2. So that's going to be a pattern. If this side was 5, this side was 5, the hypotenuse here would be 5 squared root of 2. If this side was 8, magically, and this side was 8, magically, then this side would be 8 squared root of 2. So that's a pattern that forms with our isosceles right triangles. We kind of use it for advantage to find pieces a little bit faster. What I'm going to explain is that if each side of this isosceles right triangle is some measure x, then the hypotenuse is that measure x times the square root of 2. So opposite the first 45-degree angle, because it's isosceles, these two angles would be equal, is a measure of 1, or a. Across from the other 45-degree angle is a measure of a. And across from the 90-degree angle is that measure times the square root of 2. These two setups kind of help us find the hypotenuse or the leg a little bit faster, rather multiplying by radical 2 to get to the hypotenuse, or to undo, if I gave you the hypotenuse to find one of the sides, you divide out the radical 2. So we're going to look at the following two examples. So here we have triangle MOP is an isosceles right triangle, with O being the right angle. We'll put M and P across the hypotenuse. If little m is 6 radical 7, that means little p is also going to be 6 squared root of 7 since it's isosceles. The hypotenuse, we know from our rule, is x times the square root of 2. So our value of x is the measure of the side they gave us. So we're going to put in 6 square roots of 7. So to simplify, we take that 6 squared root of 7 times our square root of 2 equals 6 squared root of 14. So that's the measure of little o. Now we found little p already because it was isosceles. It just jumped across. Okay, in exercise 2. Triangle MTO is an isosceles right triangle with angle T as the right angle. So again, M and O is our hypotenuse here. If little t is 5, okay, that's our hypotenuse across from our right angle, we need to find each of the two sides. So the setup from the top of the page here says, in order to find the leg, we take the hypotenuse and divide through by a square root of 2. So in order to find the leg, we're going to take the hypotenuse and divide by radical 2. So our leg will equal 5 over radical 2. And again, from our part 1 practice, we need to rationalize. So multiplying by rad 2 over rad 2 is 5 squared root of 2 over 2 will be the measure of each of these legs. So depending on what piece they give us, you kind of just sub into that little format, x, 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 rad 2, or a, rad 2. So x and a is kind of interchangeable, just as a variable that the two sides that are equal, you take that measure and multiply by the square root of 2 for your hypotenuse. The next diagram is our example of a 30, 60, 90 right triangle. So looking here, we know our right angle is down to the bottom right. That's our 90-degree angle. And just kind of eyeballing it, this top angle is going to be our 30-degree angle. The bottom angle is our 60-degree angle. So we have 30, 60, 90 right triangle. Remember, across from the 30 is always our short side. And that short side, let's say it's the measure of 1 unit long. across from the 90-degree angle. So we have the 30-degree angle, 60-degree angle. We're going to talk about this radical 3 and where it comes from in a second. If across from the 90-degree angle, if that's a measure of 2. Now these are ratios, meaning if this was 4, this would be twice that measure, or 8. But these are a ratio of 1 part across from the 30 to 2 parts across from the 90. Now if we take these measures and attempt to find the third side here, we can use the side again. 1 squared plus x, which is across from our 60-degree angle, equals the hypotenuse squared. So theoretically, if 1 was across from 30 and 2 was across from 90, we could solve 1 plus x squared equals x squared, and when we subtract our 1, will equal 3. Therefore, x equals the square root of 3. So this ratio shows up every time. If this was 4, this was 8, this would be 4 radical 3. So again, these go in order, and the way I help decide between the two rules, the first rule we had 45, 45, 90, meaning 2 measures, 45 degrees repeats and 90. There's really only 2 digits in that that ratio. That's where we use the square root of 2. The 30, 60, 90 right triangle, there's 3 different angle measures. That's when their square root of 3 comes in. Now the ordering is also important. 30 is their smallest angle, is your smallest side, 1. Square root of 3, if you see my calculator here, the square root of 3 is about 1.7. Goes across from your 60-degree angle, your middle measurement. And 2 is across from the biggest angle, 90 degrees. So 1, 1.7, and 2 are kind of already in order when you think about 30, 60, 90. So across from your 30-degree angle is some measure A. Let's say that was 5. Just tell you I had a triangle and made this side 5. Therefore, across from your 60-degree angle is going to become 5 square roots of 3. And across from your 90-degree angle will be twice 10. So we could multiply these triangles bigger as we go. So looking at exercise 3, let's see what they give us. Triangle rat. Kind of drew, that's wrong. Read the question, Miss Locke. The 90-degree angle is A. R, I'm going to put up top because this angle again appears a little bit smaller than our bottom angle. At 60 will be T. So here we have a 30, 60, 90 right triangle. They gave us the degrees. Little r is 12. So across from r, they give us a measure of 12. We know across from the 30-degree angle right now is a measure 12. Across from the 60-degree angle is going to be something 3. Across from the 90-degree angle is 2 times x. So the x measurement, again, I'm kind of replacing our little r with a variable x here. We have x, across from 60 is x square roots of 3, and across from 90 is 12x. So if the x measurement they give us is 12, across from the 60-degree angle is now going to become 12 square roots of 3, and across from the 90-degree angle, twice 12 will give us the hypotenuse to be 24. So in that case, little a was 24, and little t is 12 radical 3. Okay. Moving down to exercise 4. Now I'm going to start this example by drawing in my picture, seeing I have my 30, 60, and 90. I'm sorry, my drawings are a little crazy today. There we go. So L is our 30-degree angle. We're going to put that up top. M is 90. And T is the 60-degree. Okay. So automatically, before I even go farther into the question, I recognize it's my 30, 60, 90. So across from 30, I'm going to call this side x. Across from 60, I'm going to say this side is represented by x square roots of 3. Across from m, we're going to state that side is 2x. And again, that's a ratio from the top of the screen. That's that pattern that forms every time. So when they give you p is 16, that's not the easiest case here where it's just their x value. Little p is across from the 60-degree angle this time. So what we're going to do, kind of like a little rule, is you're going to set the side equal to each part of your rule. So since this 60 across from the 60 should be x squared roots of 3, and they're telling us that measure for this example is 16, I'm going to say that 16 equals x squared root of 3. So to find the measure of x, which will be my little l, we're going to divide by the square root of 3 so that x stays alone. So here, to rationalize, we have 16 square root of 3 over 3. Because remember, and again, I can fast forward, multiply by radical 3 over radical 3. So we get 16 square root of 3, and then the denominator is 3. And that gives us side x. So if our x measurement is 16 rad 3 over 3, then our hypotenuse would be twice that whole thing. So side m is going to equal twice 16 square root over 3. Will give us, not so pretty, but it gives us 32 square root of 3 over 3. The final answer there. Moving ahead to exercise 5, we have triangle mat, where R is the 30-degree angle, A is the 60-degree angle, and C is down below. If little a is 5 square root of 3, that is the measure of our hypotenuse. Our hypotenuse is usually represented by a 2x from our ratio. So if we say that 2x equals 5 square root of 3, then to find the x value from my picture, x would be across from the 30-degree angle, where x times the square root of 3 is across from the 60-degree angle. So let's find the x value by dividing by 2. So x equals 5 halves. I'll toss that radical 3 in our numerator. So that's our little a. Example is measure, I'm sorry, that little a, little r. That's little r for this example. So here we have 5 radical 3 over 2 is the x measurement based on what they gave us for the hypotenuse. Now to find the third side, we have that measurement times the square root of 3. So to find c, we're going to take 5 radical 3 over 2 and multiply that by radical 3 over 1. So our final answer, the radical 3, gets multiplied, I believe becomes 5 times 3 divided by 2, 15 over 2. Screw my eraser, sorry. So looking ahead, the next page of notes is a quick equation for finding area of an oblique triangle. I'm going to come back to that in 2 seconds, but if you would like to try those special right triangles, this page here, I'm going to ask you to do on your own. So I'd like you to pause the video, try these special triangle questions, and I'm going to post the answers right now. So if you try these, pause your video, try them on your own, and then come back to the video. I'd appreciate it. In this picture, x would be 7 because it's across your 30-degree angle, so that's always half of your hypotenuse, and y equals 7 square roots of 3. Number 8, across from the 30-degree angle gives you, I'm sorry, number 2. 8 is your x value for our ratio. So across from the hypotenuse is twice x, would be 16. And across from 60 is roots of 3. Looking at number 3, this is a 45, 45, 90. So here our hypotenuse always equals x square root of 2. So when we set that equation up, x radical 2 equals 12 divided by radical 2 across, we have to rationalize. Gives us 6 square roots of 2 would be, and 1 also equals 6 square roots of 2 because it's isosceles. Number 4, these two sides are each equal. So x is 6. The hypotenuse would be 6 square roots of 2. Number 5, across from the 60-degree angle is 4 radical 3. Per our ratio, across from the 60-degree angle should always be x square roots of 3. So the x value will be 4, which is represented by the variable y here. So across from the 30-degree angle is that measure in front of the square root of 3, and the hypotenuse is twice the measure opposite 30. So it would be 8. 8 and y 4. Number 6 is very similar to number 3. So here you should get x and y equal 5 radical 2. And for this last example, this 8 is opposite the 60 degrees. So here we take x radical 3. Now again, I'm not thinking of that as the x value. The x I'm thinking about here is the measure opposite 30-degree angle. So it's really going to be our y. So let's just y radical 3 8. And of course, we divide by the square root of 3 and then rationalize. So here, y in our case, y there, equals 8 radical 3, 3. And the hypotenuse is twice that measure. So value x, which is our hypotenuse here, would be 18 square roots of 3. So those are a few quick examples to practice your special right triangles, and I'll describe on our homework in a minute. The very last part to our notes today is area of an oblique triangle. Typically, we have triangles, and when we need to find the area, we are always given a base and a height. So if this was the height x and this was the base y, area equals base y. However, we don't know measures when it's not a right triangle. So oblique means no. So we use our sine function to help find the measure. So in order to find the area of a triangle, you must have side angle side. So you need two sides of any triangle, the angle shared between those sides, and you can sub into this formula. K is the area of an oblique. Okay, so that's what the letter big K stands for. So if we needed to find the area of this triangle, again, we don't have a base and a height where we could go back to our area equals a half DH formula here. So instead we use area, or K, half the two sides. So the two sides being 12 and 9. So half of 12 times 9. Oh, no. Sorry about that. Let me open up with another assignment. Just canceled it out on me. But that example, we were at a half of 12 times 9. I can get this out of here. Here we go. So here our area half 12 times 9 times sine 30, which is the angle between them. So if we were to jump into the calculator, a half times 9 times 12 times sine of 30 gives us the area of that triangle, units squared. Looking at number 7, triangle CLV. L is 80 degrees, C is 65 degrees. Now, if we know two angles of a triangle, we find the third by adding and subtracting from 180. So I'm going to find that V is 35 degrees. When they give us little l is 22, across from that 80 degree angle is going to be a side of 22. And across from C angle is a side of 17. Again, we need that side angle side. So we needed angle V here in order to substitute it. So here, this piece, we're going to use a half, 17 times 22 times sine of 35 degrees. Okay. I figured out how to get rid of this earlier. Now aren't getting there. 25 times 17 times 22 times sine of 5 degrees should give us 107.258. They don't tell us where to round to. I would like to go 4 decimal places, so it's 2. It will clearly state on your homework here in a second. Fast forwarding to the homework, I know a lot of students usually struggle at the very first page. I just want to explain. Using this diagram, use the rules discussed from the 30, 60, 90, or in this case, this example is 45, 45, 90. So here, each column, number 1, number 2, number 3, number 4, is me changing the measure of each set aside. So if little k is 17, and you know little k is one of the 2 legs across from the 45, and little l is across from the 45, and across from the 90 is your j. We know k, l, and j are across from each of the sides. So this is always your x, x, x squared of 2. So if little k is 17, then little l would be 17, and j would be 17 square roots of 2. So in the next case, number 2, L and K are going to be equal. So we have 3 radical 5 are each of the legs. Therefore, the hypotenuse is 3 radical 5 times the square root of 2 would become 3 radical 10. So that's how this is kind of working out in each case. So that should make sense for number 1. Number 2, remember A, little a is going to be across from the 30 degree angle. And let's say it like this. A squared root of 3 is going to be across from your 60 degree angle. And across from little c is 2a. So if you think of this as your a value, your a squared root of 3 value. So in this first case, we have 3 radical 3. And c would be twice a is going to be. You can kind of follow that along. So for number 2, if that's my a value, 2 squared root of 3, I'd multiply that again by my square root of 3, because we're kind kind of subbing in just for the A. So this would be 2, 3, 6 here. So that helps fill in the table for the front page. The formula for number 2, remember, is A equals half AB sine of C. And again, these might not sub in perfectly. You really need to make sure you have that side angle side piece when you're drawing those pictures. And helping you with the diagram for number 4, top of a 108-foot high building, an observer measures an angle of depression. To the bicycle on the sidewalk. So remember, your angle of depression, if he's at the top of the building here, windows, your angle of depression is out here. It's 29 degrees 40 minutes. That is always the alternate interior angle to the angle of elevation, 29 degrees 40 minutes. Okay. So then you can measure to this bicycle. Really bad diagram. But they're trying to find the distance that bike is to the base of the building. The building is 108 feet tall, if that diagram helps at all. Number 5, vertical pole that casts shadow on ground. So the vertical pole we will assume is perpendicular to the ground. If its pole is 20 feet and shadow down on the ground is 16 feet, you're trying to find the measure of the angle of elevation to the nearest 10 minutes. Going back to complementary trig functions, remember here that a measure, let's say 30 degrees equals cosine of 60, and that those two measures always sum to 90. You're going to take what's inside here next to cosine and what's next to x equals 90 first. So there's a couple hints for each page of your homework. Good luck. We'll talk to you soon.